4. As long as wars have been fought, the human body has been both the weapon and the weakness. Armies could build stronger swords, sharper arrows, faster guns, but every battle still depended on flesh, bone, and muscle. Soldiers marched until their legs failed. They carried weapons until their backs broke. They fought until exhaustion decided victory more often than strategy. For thousands of years, warfare adapted to the limits of the human body. Now, those limits are being challenged across secret military laboratories and restricted testing grounds. A quiet transformation is taking place. Engineers are no longer asking how to make soldiers train harder. They are asking how to make soldiers stronger than biology ever allowed. Not through drugs, not through genetics, but through machines that move with the human body, amplify its power, and erase the boundaries of fatigue. This is the rise of the exoskeleton soldier, and it represents one of the most profound shifts in the history of warfare. An exoskeleton is not armor in the traditional sense. It is not worn to block bullets alone. It is a mechanical structure designed to enhance movement itself. Motors, actuators, and artificial joints align with the human body, supporting legs, hips, spine, and sometimes arms. Sensors read intention in milliseconds. When the soldier moves, the machine moves with them. When the soldier lifts weight, the machine absorbs the strain. The result is a body that feels lighter, stronger, and more resilient. What once existed only in science fiction, powered soldiers marching effortlessly through fire and chaos, is now being tested by real militaries with real consequences. The earliest military interest in exoskeletons was not about combat dominance. It was about survival. Modern soldiers carry enormous loads: body armor, ammunition, communication systems, night vision, batteries, food, water, and medical supplies can easily exceed 40 kilograms through over long missions. This weight destroys joints and spines. Even elite soldiers suffer permanent injuries long before retirement. Exoskeletons offered a solution. Early systems focused on logistics and support roles designed to transfer weight directly into the ground. They reduced strain on knees and backs. Soldiers could march longer, recover faster, and return to duty with fewer injuries. What surprised military planners was how quickly these systems changed battlefield capability. A soldier who is less fatigued is more alert. A unit that arrives fresher fights harder. Endurance itself becomes a tactical advantage. The United States invested heavily in early prototypes, testing exoskeletons with infantry units, special forces, and logistics teams. These suits were intentionally minimal, focusing on lower body support rather than full armor. They allowed soldiers to kneel, run, climb, and crawl without restricting movement. China pursued a different approach. Its programs focused on terrain dominance. Exoskeletons were developed specifically for mountain warfare, border patrol, and extreme environments. Soldiers wearing these systems could transport heavy equipment across steep terrain, once considered impassable. Entire supply chains were reimagined. Russia explored strength amplification combined with armor integration. Their focus leaned toward heavily armed troops capable of carrying large-caliber weapons without sacrificing mobility. The idea was simple. If one soldier can do the work of three, force structure itself can change. Skis. Each nation is building the same future in its own image. Modern military exoskeletons are not clumsy machines. They are sleek, skeletal frames built from lightweight alloys and advanced composites. Electric motors provide assistance only when needed. Sensors measure balance, pressure, and motion thousands of times per second. The most important breakthrough was control. Early systems failed because they reacted too slowly. A human body moves instinctively. Any delay breaks balance. Modern exoskeletons predict motion. By reading muscle tension and body position, they anticipate the next step before it happens. To the soldier, the suit does not feel like equipment. It feels like enhanced ability. With this enhancement comes transformation. Soldiers wearing exoskeletons can carry heavier weapons without slowing down. Heavy machine guns, missile launchers, and advanced sensor systems become more mobile. Urban combat changes when troops can sprint upstairs in full armor without exhaustion. Long patrols become shorter not in distance, but in fatigue. This technology reshapes tactics at the most basic level. But strength and endurance are only the surface. Advanced exoskeleton programs integrate digital systems directly into the suit. Heads-up displays, project maps, enemy positions, and mission updates into the soldier's vision. Biometric sensors track heart rate, hydration, stress levels, and injury. Command centers can monitor unit readiness in real time, knowing exactly when a soldier is nearing physical limits. In future systems, artificial intelligence will assist movement itself. The suit may stabilize aim during recoil, it may optimize posture when firing. It may recommend movement paths that reduce exposure to enemy fire. The soldier becomes part of a larger machine, not replaced, but augmented. This is where the debate begins. Warfare has always balanced technology with humanity. Exoskeletons blur that line. When a machine assists movement, who is truly in control? If an AI-enhanced suit suggests a tactical decision, is the soldier following instinct or instruction? More troubling is endurance. A soldier who feels less tired may be pushed harder. Missions may be extended. Recovery times shortened. The body may be protected from strain, but the mind still experiences stress, fear, and trauma. Military psychologists warn that enhanced capability can change behavior. Soldiers may take greater risks. Confidence can turn into overconfidence. The psychological weight of being superhuman carries its own consequences. Then there is the ethical dimension. If exoskeletons become standard equipment, refusing enhancement may no longer be an option. Soldiers may be required to fight augmented. The distinction between natural ability and engineered performance disappears. Military service becomes not just training the body, but upgrading it. An arms race follows naturally. Once one nation fields exoskeleton and troops, others must respond. Falling behind becomes unacceptable. Just as body armor and night vision became standard, powered enhancement may become mandatory. The battlefield itself evolves. Urban warfare favors agility and stamina. Mountain warfare favors load-bearing power. Arctic warfare favors energy efficiency and thermal regulation. Exoskeletons can be customized for each environment, creating specialized units with unprecedented effectiveness. Looking further ahead, exoskeletons may integrate directly with armor plating and defensive systems. Hybrid suits could deflect shrapnel, absorb blast shock, and stabilize the body under impact. TOR, combined with autonomous drones, AI targeting, and networked command systems, the individual soldier becomes a mobile combat platform. Yet for all this technology, one truth remains unchanged. War is still fought by humans. Exoskeletons cannot eliminate fear. They cannot remove moral responsibility. They cannot decide when to show mercy or restraint. Beneath the machine is still a human making choices in moments of chaos. The danger lies not in the technology itself, but in forgetting that truth. As exoskeleton soldiers become reality, warfare enters a new phase. Not fully robotic, not purely human. A hybrid era where strength is engineered, endurance is extended, and the cost of combat is transformed. The Superhuman Army is no longer a fantasy. It is assembling quietly, piece by piece, test by test, soldier by soldier. And when future wars are fought, historians may look back and mark this moment as the point where the human body stopped being the limit. This is WarTech Frontier, and this is the future of the soldier.